Hey guys, in my introduction, I showed you some of the parts and stuff I got and talked about kind of clear spanning my CNC machine. And then I just kind of got in a SketchUp and drew this basic model here for you. And not really for you, for me to freaking, get into how I'm going to build this. I'm going to talk to you about some of my theories here. First thing, I'm able to clear span all of this with these big rectangular steel tubes here. Some very heavy duty stuff I talked about in the last video. And then the linear guides I have will go on top of here. I didn't feel like modeling them in this. I mean, I could have, I might as well have, but you can see they'll go right here. And I've kind of put these are how I kind of plan on attaching it. 1/2-inch steel bar, weld that together, and that'll go on top of the linear guides on the blocks. And I came to this kind of design. There's another way I could do it. I could have just put the linear guides down lower. Like, I pulled up some pictures of see how this guy here, he has his machine set up where the linear guides are actually down here. He's still driving it with just one stepper motor in the middle, and that's kind of what I plan on doing. I mean, that's definitely what I plan on doing. But instead of having his linear guides all the way up here, he kind of moved them down further. And you know what? Doesn't seem that bad. My only concern is the further down you put your linear guides, that creates more of a twisting action on your gantry than having the center line of it being aligned with the force. It's kind of hard to explain, but if you think about it, you'll understand what I'm trying to illustrate. It's kind of the same thing with like one of these here. And you know what? These linear guides aren't that much further than the router, further down. And frankly, like the linear guides they're using on this machine here that I pulled up, those look like a THK style, where they have the linear balls, 4 rows of circulating balls going around. And these type of linear guides are actually way better, and I'm sure they have no issue with a little bit of extra force exerted on them from the type of the twisting you have going on here with this gantry type of setup. So if I was using that type of linear guide, I would have just went with something like this. But I'm not. I'm using some cheaper linear guides from eBay, and they don't seem to really hold up, like that. So I feel like my best design to really get the most out of this machine will be to put the linear guides on the same plane, very close to where the cutting head will be from the router, and that will give me the least amount of twist out of the gantry, if that makes any sense, since I'm going to be building a real stiff gantry. And then another thing to even minimize that more is I can put my drive stepper motor right here. This will be a bar going across that'll attach to the bottom of the gantry. I'll be able to come up off of this and put up another piece of block or whatever up off of that, probably even higher than that. Yeah, about right there. Then I'll put another piece across here. Something like this. And then I'll be able to actually drive it that way. So then everything from the drive to linear guides to the cutting head, all the forces are pretty well centralized. I mean, it will be transferred up through here, but this gantry should be stiff enough to not really give you any type of deflection from that. So I mean, I'm really building this to be pretty accurate, probably more accurate than you need for a CNC router, especially a wood CNC router. I mean, where we could get away with 1/100 of an inch. So if I really think about it, I probably could have just did more basic framework, just some 2x2 tubing, because this right here is 2x2 tubing. This is 3x3 for the legs, 2x2 here, And then I also threw another 2x3 piece going all the way down the middle here, and then these are just more 2x2 tubing just to support the tabletop. And yeah, thinking about it, I probably could have just, you know, did a whole 2x2 tube structure and put the linear guides down lower. But the thing is, let's think about this too. Look, I wish I could get a side shot of this guy's machine, but his whole top is just the 2x2 framing. And you know what I mean? That's probably okay, but look, we're talking about potential flexing here, deflecting. Even though his linear guides down here are theoretically supported pretty well, even though in his design I don't see actually any supports down here. He should have some more supports going, because he's definitely getting deflection from that 2x2 tube right there. So he should really have that framed up pretty better than that. But also, even if you do it like this, you're going to have to clear span your tabletop. So think about that. Even though it's lighter than probably the gantry would be, you still may be getting some deflection from your tabletop too. So let me see if I can find anyone else that built something like that. Now, oh, here's an interesting one to look at. This guy's on YouTube, and he's using 2 drive motors, obviously, or 2 drives on either side for the X. And this isn't really that bad. It's kind of a cool setup. Yeah, I don't think it's that bad, but you are getting, again, if his material is down here, you're getting a whole lot of twisting motion out of this as you're cutting. And I see he's using the same type of linear guides that I'll be using. These things are not, I mean, I really want to keep the load as much pressure downwards on him than up, because once you get that twisting motion on here, it's gonna be pulling up on these blocks, and they aren't designed that well for that, to be honest with you. I mean, obviously they can do it, but I don't think they're really that great. All right, here's another example, and this isn't bad. Again, these people are using 2 motors, one on either side to drive the X. And my gripe with that is, if you're using steppers, which we are probably, most of us, we're not using servos with encoders, that's open loop. So if something happens where one of them skips a step and the other one doesn't, or what have you, we're talking about the gantry getting cockeyed, it's getting out of alignment, and who knows, are you going to check it constantly to be sure it's perfectly aligned or what? You know, I don't like that idea. That's why I want to drive mine with just one single motor down the middle. That's why I want to do it like that. So the 2 kind of worries me. So I could make this even more accurate, potentially accurate too, by lowering this gantry, making it, you know, bringing it down. Because theoretically, I'm only really going to be cutting plywood. That's my main plan for this. I actually do kind of plan on maybe milling some aluminum and stuff on this, and that's possibly why I'm trying to make it as robust as I am, because I do possibly have some aspirations to mill a little bit of aluminum. But I did kind of leave a little bit of space here on my Z to give, in case let's say I want to route something, you know, that may have some thickness to it. I don't know. I have no idea what I could, but I could see there being something where I want to route it, and I think I have like 10 inches here that I'll be able to use on my Z. Yeah, it's like 10 inches or so. And, you know, hey, if there's something comes up where that's that thick, I want to, you know, work with, that'll be cool. You know, this thing is going to weigh a lot. I actually calculated this to weigh like 800 pounds. Because I want to talk to you how I'm going to build this, because that's a real big thing here. It's really tripping me up. Thinking about drawing this out on here and thinking about how exactly I'm going to build it, because the hardest thing for me to get my head around is how I'm going to build this all square and make it level. The tabletop and this base stand, let's call this the stand, let's call this the tabletop, are going to be welded together separately, but sort of as units. So they will be able to come apart, and I'll be able to unbolt right here. Kind of see this 3x3 leg. I plan on notching it out, and that way I'll be able to put a bolt. Let me pull out a circle here. I'll be able to bolt it through here, and then I'll be able to bolt it through here on each corner, bolt the table to it. So those will be separate, completely separate deals, and they will be able to come apart. And I'm doing that because, well, one reason, what if I put this stand somewhere and potentially I can level the feet out, but I don't manage to get the tabletop totally leveled out, and I need to shim it up through here. I'll be able to do that with the bolts to completely square it up. And another thing, I actually built this stand purposely to have some twist in it, to be able to. So if you see, all I got coming across here is just a 2x2 tube, and then on the other side, and I have it braced up so it'll be stiff. It won't move side to side or back and forth. But if you're looking at it from this way, it will be able to twist this way or that way a little bit, because these tubes, you know, they're just 2x2 tubes. And that's a part of my plan to be able to get this thing squared up and completely leveled out to perfection, because I'll put leveling feet on the bottom of these four corners. Okay, probably just giant bolts, and I'll put some steel plate under them, so I'm not just putting a bolt on the concrete floor, probably cracking the concrete. So I'll do that, and then I'll be able to level it out from here. And if that's not enough, like I said, I'll have this bolted here. I can shim each corner up individually if I need to. So that's kind of my plan for that. And then it comes around to actually building this. I've had a couple theories. It's building, now when designing something in here and then actually taking it to manufacture it is a completely different thing, because how am I gonna make sure that all this stuff is completely square to perfection? And that's something I'm gonna be very picky about. I plan on making a jig, and I plan on making the stand, these short ends of the stand first on a piece of plywood. I'll make a jig where it's completely squared up, so these legs are perfectly square, and then I'll probably take them and do the side. I'll make this whole stand first as square as I possibly can, precise as I possibly can, and then, this is one of my theories, I'll possibly start by sticking a piece of plate on here or something, or tack welding something, just kind of on here, just right here, as a bump stop, something, and then I can set my side, these heavy freaking rails up on the side, and that'll get me a start point. But hopefully the trick is going to be to get this 2x3 tubing here, make sure this stuff is completely flush on the top. That's super important for this stuff to just be aligned perfectly. So it's going to be kind of a challenge, and this will be welded together up here, because this is part of the tabletop. So this stuff will be welded right here, as well as all of this will all just be welded together. And I estimate just that tabletop alone is going to be 350 pounds. So, and my other theory is to actually just build the tabletop first, kind of upside down. Just think about it, might be kind of easier just to do it like that. But I don't have a concrete floor, a level floor that I totally trust to also be squared and level. So you got to think about that. It's a lot of thinking about how you don't have a floor or surface to build anything on that's freaking level at all in the first place. because I mean, no concrete floor is perfectly level. I suppose I could get a couple layers of MDF and stack them up to be bigger than this tabletop and go off of that. And that actually might, if I were to do it that way, but then I would have to build like a gantry with a chain hoist to actually pick this tabletop up and flip it over and get it on top of this stand. So that's a whole to do. You know, that's not for the faint of heart. This is a big, heavy project. It's pretty serious. So those are my ways of potentially going about constructing this. I think I'm going to start with the stand first, try to get it as square as possible, and then I can just actually build it like that. And my plans, if I ever have to move it, because this thing's going to be in my garage, I'm kind of worried because it's kind of close to my neighbor's house. It's actually a vacant house right now, and it's probably going to be that way for another year or so. But if I get neighbors, I'm not going to be able to use this thing. One of my options in my garage is to build like a soundproof wall, or even outside, but go as far as soundproof in the garage, soundproof fence, do something crazy. But ultimately, that's probably not going to work, and I'll have to move this whole thing somewhere else. So likely, if I have to do that, I'm gonna have to make a cart with some giant casters on it, pneumatic wheels, just big old tires, and jack this up and just move it as a whole thing, probably. So there's some challenges to think about. And of course, I didn't even touch on this. I've mostly been focused on the x-axis. I didn't focus on the y-axis or the z. That stuff's not, once I get the linear guides mounted up here, I'll be able to get a piece of plate steel and to make my z-axis off of. So that's all relatively straightforward. My big thing is how to make a nice solid x-axis that spans 9 feet, basically. And I think this is the best way to do it. It's the best way I feel about it. Not to knock anyone's other CNC machines at all. I mean, obviously all this stuff works. It just all makes me very skeptical. You're putting a lot of extra force on those linear guides, and I'm sure they can take it, but if you don't have to, then hey, that's kind of engineering, is making something as easy on the machine as you can. Why make it harder on the machine when it doesn't have to be? I always like this guy's machine right here. This has kind of always been the inspiration for my machine. But again, if you look how low he has his linear guides, and that's not, again, it works. But something about it. It's like you're putting a lot of extra force where you don't need to. Obviously, his machine works just fine.